Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. And what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but they will apply a lot of the same principles apply over in the UK as well. Now, if you do have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring live chat. If you're watching this after the premiere, then just feel free to leave a comment underneath the video and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on's diagnostic technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had 30 different franchisees I worked with, as well as the shops that they serviced, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru. So I worked in a dealership, and over time, I guess, just became the default diag guy in the shops. I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bed. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic today is HVAC electronics. So we are going to focus on mainly the inside the car stuff, not the outside in the engine based stuff. So AC, compressors, condensers, evaporators, all that stuff, that's really best left to a whole other topic on its own. And I think we might end up doing that one maybe next year sometime. But today, for our purposes, what we're going to talk about today is going to be the sensors, such as maybe the inside and outside temp sensors. There's a bunch of different varieties of those. The sun load sensor, also there's a windshield temp sensor we'll talk about. Blower motor, a couple different ways to control a blower motor. We have the old way with the relays and the resistors, and then newer ways with actual control modules. We'll talk about both of those. And we'll talk about the actuators, right? The mode door, blend door, recirc actuators, all those different arms and linkages that are involved underneath inside the heater box on the vehicle. So we'll go through all that, couple tips and tricks, tests that we can do with them, and then we'll go live on the tool to show some other tests that we can do in there as well. So we take an overview look of a modern day SUV. So this, I think it's like a 2018 Explorer. And it has, front AC, it has rear AC, right? Because they're big enough nowadays where they're kind of long enough where you want to have that rear AC in the vehicle. So it has a blower motor and all the accessories up in the front, and then also has the blower motor and all the different doors and actuators in the back as well. So it's like we have two duplicate systems, and then we have, of course, the AC and the heat components that go in the back as well. So as I said, we'll be focusing on the stuff that's inside the passenger compartment today, because we can see there's a lot of different things on a vehicle. So we got the control module here. This is a modern vehicle with a control module, blower motor outputs, actuator inputs and outputs, temperature sensors, evaporator temp sensor, sun load sensor. Really not going to concern ourselves with any of that stuff like the AC clutch relay, like I said, or any of that. That's, as I said, probably best left to its own session later on. So as of for today, we're going to talk about all of that stuff there. So first off, let's talk about a few of the different sensors on a vehicle. First one is a sun load sensor. So what this does is it's a photodiode. So it takes the energy from the sun, or the solar radiation as it were, and converts it into a voltage signal that gets output to the computer. So the computer uses that as an input. So this is based on the intensity of the sun. So if it's in the middle of the summer, in the middle of the day, and you're outside with no shade, it's going to be a lot higher load than it would be, say, later in the day in the winter. And it's getting dark at 4:30 in my world right now. So when it gets dark earlier, or the sun is not as intense, the radiation isn't as intense. So the computer can compensate accordingly based on the conditions. So if it's high noon in the middle of July and we have a high sun load, then maybe the air conditioner blows a little colder to get the temperature where it needs to be, or maybe the automatic. So you're usually using the automatic sense. So If I got to keep the temperature at this, we need to know what the load of the sun is, right? So it needs all these inputs in order to do that. Also note, just thought of this. So on some vehicles, depending on how they're equipped and what kind of system they use, you may do a code scan inside the bay where there's no sun, and you could get a code for that. Right? There could be a code for an error with the sun load sensor because, well, it's got no sun on it because you're in the bay when you're doing these tests. So just be aware that it could be an erroneous code that you might get, and just in that case, disregard it. If you're sitting inside and it says, I don't see the sun. Well, yeah, it doesn't see the sun, right? And this can be tested by shining a light on it too, by the way, which makes it easier. And then we have the ambient air temperature sensor. So this one is outside the vehicle. It's a thermistor, and we're going to see a lot of different thermistors in this training here. And basically, what it is the resistance of the sensor changes based on temperature. So they call it negative coefficient thermistor. So it goes down as the temperature goes up. So the resistance goes down. Converts ambient air temperature to a voltage used by the control module once again as an input. So I need to know what the temperature is outside too. Usually it's in the front bumper, and usually I have seen them out exposed in the air, but a lot of times they're maybe in behind the bumper fascia, so it doesn't get the direct blown air on it as you're driving down the road. Also note, sometimes depending on the vehicle again, if there's been a large temperature swing since the last time the vehicle moved. So let's say I have a panel on my dash that says what the temperature is outside, right? And let's say it's 40 degrees on the panel, but I know it's like 65 degrees outside. Well, that's not right. Is there a problem with the sensor? Oftentimes, the sensor won't even start reading until the vehicle is moving a certain distance, a certain speed. So just also be aware of that when we're trying to test and trying to troubleshoot. If there is a problem, oftentimes the vehicle needs to move a bit, drive it down the road for a little while before it gets back in sync with the temperature. Seen that happen a few times. Also, the way that the sensor is built, not only where it's located, also helps shield it from that moving air as well. Just kind of the thickness of the plastic on the outside, etc. Then when we get into the interior, we have a cabin air temp sensor as well. And sometimes you have multiple cabin air temp sensors. Once again, a thermistor converts the in-car air temp to a voltage once again. So the control module uses that as an input to know how warm is the cabin. So if I'm using automatic AC and I want to have it set to 80 degrees, and this sensor has air flowing through it and it's reading 80 degrees, well, then the vehicle's computer, well, the HVAC computer knows that it needs to cool it down. It needs to send out more cold air versus not to cool it down faster. Usually it's in the center of the dash just to make it kind of where you're sitting. It's good to have that air around about your level, not up in the ceiling or not on the floor. It's kind of at wherever you're sitting type of level. You'll usually see like a little grate in the dash, and it's right behind there is usually where that is. It's just 2-wire sensor, just like all the others. And it looks like this. So that's that little thermistor element. So this is looking right down the barrel of that temp sensor. Ambient temp sensor would look very similar on the inside too. I noticed I have that mislabeled, but so this is the cabin air sensor. And then also on some vehicles, I know on GMs for sure, they have these air duct temperature sensors in different parts of the duct. So you can see the like the insulation right there. It's a little foam, and it clips into the duct itself. Could have it in the floor duct or the face duct or the frost or what have you. And once again, it's that thermistor element, converts that temperature, whatever it's reading for the air flowing over it, to a voltage that the control module uses to understand how cold is the air or how warm is the air coming out of the duct at this time. And they can make it calculations based on that. Then also we found this windshield temp and humidity sensor. Now I know GM vehicles use this, other manufacturers may or may not sure, but I did definitely find it on a bunch of GMs. Combines temperature and humidity sensors as well as a temperature sensor for the humidity sensor. So it measures the windshield temp, the cabin humidity, and the humidity sensor temperature itself, and that allows it to adjust relative humidity or see what the relative humidity is in the cabin. The control module uses that as an input as well, mounted to the upper windshield. So in this case, on the vehicles I looked at, it was up by the camera, where the lane departure camera would be. So that's up measures the temperature of the windshield. That vehicle also has a sun load sensor on it as well. So multiple inputs going into this HVAC module in order to calculate how to optimally cool the car or heat the car, keep the temperature where the driver sets it. So just be aware that you may or may not get codes on these. So oftentimes, this is just a small sampling of codes that you might be able to get on sensors or actuators. So we have like opens and shorts, room temperature sensor, outside air sensor, open and short, ambient evaporator sensor, which is on the evaporator core, sun load sensor. You could get another sun load sensor code, like I said, if you're in the shop. And then the actuators and the doors open and short circuit as well. So just be aware that they are B codes as well. So you'd have to check those in the HVAC module. They are B codes for body control codes. So there are quite a few codes you can have, opens and shorts, but not necessarily mechanical failures depending on how the car is. So just be aware you want to electrically test these when we're testing them. We'll talk about how to do that when we go live on the tool. Actually, we'll talk a little bit about it right now when we move on to the blower motor. So after the module gets all these inputs, it needs to turn on the blower or controls the blower motor. Now, depending on how the vehicle's set up, a couple different ways we can do this. Now, this first one we're going to look at is 2011 Subaru, and that is more of the classic style, I guess, from back in the before times, before we had these modules. And this uses the blower motor resistor. So it has a little resistor module that's in there. And depending on where we have the switch, so there's the switch right there in the dash, it's a manual control. Depending on that, it will send a differing voltage to the motor, depending on what it needs. So in this case, 5 to 1, it goes down this line, goes in here, and then comes back out into the motor and it has it spin slowly. And then it increases and increases until finally we get to max speed, which is number 4, and that is just straight voltage right into the motor. So it changes the current and it changes the voltage going into the motor in order to control that. So it controls the ground side of the motor. So the power comes in this side and it controls the ground side on that side. So that allows it to change the speed by this resistor right there. All right, now you can check it with a current ramp. It is a little bit different than what you'd be used to with the with like current ramping a fuel pump or something like that. So it does look a bit different. You don't necessarily see all those humps in there. Now this is also looking at on a graphing meter at a 10-second scale is what this pulls up for us. So we want to be able to see, make sure it's not too high of an amperage. You know, usually on high, you don't want to see more than say 15 or 18 amps, depending on the circuit size. Oftentimes the manufacturer will publish that. So you just want to make sure it doesn't exceed that. You want to make sure it doesn't have any dropouts or weird things going on. And then here's just another example we did when we were from low. So number 1, number 2, number 3, and number 4. So that's high right there. Now you do see there's a spike on each of these. It gets higher and higher the further we go because there's more amperage flowing. So we get a bigger jolt of current when it first clicks over. So that's like, as I said, that's number 1 on the fan, number 2, number 3, number 4 as it goes up. So we just want to make sure it steps up and steps down. That way we know the resistor is working, and we just want to make sure we don't have over amperage in there. Here's another example on a Cadillac. So this is a 14 Cadillac, and this has a controller. So the blower motor speed is controlled by increasing or decreasing the voltage drop on the ground side of the blower motor speed control circuit. The HVAC control module provides a low side pulse width modulation signal to the blower motor via the blower motor speed control circuit. So it's actually pulse width modulated on the ground side. When the blower speed control is moved towards high position, the HVAC control module increases the amount of time that the speed signal is modulated to ground. So if you were looking at this on a graph or a scope, you would see longer time on the bottom of the square than on the top of the square. When the blower speed control is moved towards low position, the HVAC control module decreases the amount of time that the signal is modulated to ground. So you'd see less time at ground, more time on the top. Also note, the design of this motor does not allow for operational bench testing. I can't just supply power and ground. Inspect the motor shaft for rust and other foreign material. Can be enabled through the use of a scan tool. So there's a functional test bidirectional control to turn it on. turn it off. You can also change the speed often, and then test for power and ground as possible, but you can't turn it on, right? You need this speed control circuit on pin 2 there in order to activate it. So it won't activate. So you got power and ground, but it won't actually turn on until it gets the speed control pulse with modulated signal as well. It's like a little logic board in there. All right, so if we look at the wiring diagram, you see we got ground, we got power, and then we got the control in here, and it's got a little logic board. So if that logic board doesn't see that signal, it's not going to turn on. So you could take it out, think, oh man, I got a problem with this motor. You bring it on the bench, you hook up power and ground, and nothing happens. You could misdiagnose this vehicle if you didn't understand that you needed to have that speed control there as well. So just be aware that these things happen. Also on this vehicle, I thought this was really interesting. I've only seen this on GM vehicles. Other manufacturers may have this, but I've only seen this on GM, so it could be others, as I said. But they have this feature called afterblow. Afterblow is a feature that dries the evaporator core by operating the blower motor after the engine is turned off. This reduces the amount of microbial growth that can create undesirable odors. The vehicle does not come equipped with the afterblow feature turned on. If the afterblow feature is required due to an odor concern, it must be enabled during this using a scan tool afterblow configuration function, which is inside your Snap-on scan tool. After the HVAC control module has been programmed for afterblow, the following conditions must be met for afterblow to operate. The engine has been turned off for at least 30 minutes. So this happens after the engine's off. The ambient air temperature needs to be at least 70 degrees Fahrenheit. The AC compressor must have operated for more than 2 minutes before shutdown. And the system voltage needs to be at least 12 volts. If all those are met, the blower motor will perform the following sequence up to 5 times, and it could last up to an hour. So the motor will be off for 7 to 11 minutes, and then it'll run for 25 to 30 seconds. And then it'll be off for 7 and 11 minutes, and so on and so forth, until it's done with the procedure. So that's a way of drying out if you got an evaporator core that's collecting a lot of water and it's just collecting inside the compartment, you know, being able to blow that out. I thought that was kind of an interesting little feature there. So we'll talk about that in a second when we go live. I'll show you where that is on the tool as well. I thought that was kind of an interesting little side note to the blower motor there. Now let's talk about actuators. So we have these different actuators on the vehicle, and depending on how it's equipped and how many different functions it needs to have, it'll have a different number of these actuators. Now, by and large, they might look a little different on the outside. They might have different arms, or then one might go in and have a little pin in the middle or something like that. But essentially, they all work on the same basic premise. It's a reversible electric motor and it has gears inside. So and the gears are plastic, by the way, so that could run us into trouble. We'll see that in a minute. Also contains a position sensor so that the computer knows where is this rotational arm in space, where is it at 360 degrees. Operates linkages. It's not usually a direct drive. Usually there's linkages involved and cam arms and things. Well, for the recirculation door, blend door or doors, depending on the vehicle, mode door or doors, depending on the vehicle as well. So here's just an example of what that would look like, where they are mounted relative to the heater box. And you can kind of see the linkages in the background here. It's not the best drawing there, but hey, I'm no artist either, so I guess I can't complain. But we can see where the two actuators are on this particular vehicle. It's on the left-hand side. And we can see where the heater core is in there as well. So they just kind of move back and forth. That's a mode door and the air mix door. So let's take a look at how this works to be able to better visualize what these actuators are actually doing inside the vehicle. So this is just a generalized drawing of a HVAC system. We have our cabin filter, which goes to outside air. We have our cabin air intake on the floor usually, blower motor, evaporator core, heater core, floor vent, dash vent, defrost vent. So in this case, we have it on recirculate. So the cabin air is coming in and it goes into the system. If I wanted to change that, we just change the recirculate button, and then it goes to outside air and it moves the flap down and allows the outside air to come in. Now also note, here's something that customers I know don't necessarily think about all that much, is the cabin filter. So and I've seen some pretty awful cabin filters. I'm sure you have too. Hey man, my air conditioner is not working very well, or my heater is not blowing very hard. Well, if that cabin filter is clogged, and I'm pulling from outside air instead of recirculating, well, yeah, it's not going to flow very well. And yeah, you might have that problem where it's not able to pull in enough air from the outside to flow the way they want it to. So definitely don't overlook that cabin filter for sure. All right, so that's recirc. And then how do I change the temperature on the vehicle? So we have our blend door to do that. So normally in this system anyways, it goes over to the evaporator and then it goes right through. This is fully over to the cold side. So we can see we don't have any air going over the heater core. If I wanted to have some air go over the heater core or full air, it's going to go through the evaporator. Now, if I want heat on, my AC is probably not going to be working anyway. So it'll just be outside, regular air temperature. Go over the heater core and then out. Now, what if I wanted a blend of the two? What if I wanted some medium air, right? Some warm air instead of hot or cold? We can do that too by moving that blend door kind of in a halfway position. And then we get our cold and our hot and they mix and then they'll go out to wherever they need to. Now, how about if I want to change where my air is coming from? So we have our mode doors for that. So that's these two over here. So right now it's going on the floor vent. So it's coming out the vent. If I wanted to change that, we close this vent and then out, now it goes up to defrost vent because of the way that my air is, the path is. And if I don't want that, I can change my dash vent. Maybe I get a defrost and dash vent. Or I can do a floor and dash vent sometimes too. Depends on how I move these actuators. And then if we wanted to go to full dash, we can just do that. Closes it up. All right, so that's on a normal, regular, single zone system. If I wanted to do dual zone, we could do that too. We just have to make some more ducting and we have some more actuators as well. So in this case, this is my recirc here. So that's my cabin air, that's my outside air, recirc door there, blower motor. And then we have the two chambers. We have the left zone and the right zone. They share the evaporator, they share the heater core. If I want to change the amount of air blowing on my face on the driver's side versus on the other side, we can use these two doors right here, which will change the amount of air flowing through the system. So it'll open or close based on demand, how fast it needs that air to flow. If I want to change the temperature, maybe I like it a little cooler on my side. Maybe my passenger likes it a little warmer on their side. We can use these blend doors down here. So there's individual blend doors for each side. So depending on where we put that blend door, we'll change the amount of air flowing over the heater core versus the cold air coming on the other side. Right? So we have these options in there. So it works on the same principle. It's just there's more actuators involved, and we are only still using that one fan as well. So what kind of problems can we have? Well, speaking of that dual zone climate control, how do I figure out if it's working correctly? Well, I can set them both at the same temperature and see if that actuator is working, right? So in this case, one of those actuators wasn't working. I got hot air coming out the left vent, no air coming out the right vent. And on the right-hand side, we see we got hot air coming out of both vents. That's after it was fixed. So we can see if we have a bad actuator or the door gets stuck. That's happened before too. Thermal camera is definitely a good way to diagnose that for sure. As you can see, we have a definite difference in whether or not that's working. Also, after we repair an actuator, if we replace an actuator in the system, we need to recalibrate. Most times we need to do a recalibration routine. So you're going to use a scan tool. So it's using a scan tool, and this is on a GMC Acadia. Using a scan tool, perform the actuator, learn the HVAC control module. Follow the scan tool direction to complete the procedure. Operate the system and verify no DTCs have set as current DTCs. If DTC B101E4B is set after attempting the actuator recalibration procedure, perform the following. Verify which actuator does not have a scan tool learn status parameter status of complete. So you'll look at the data and see whether or not that particular actuator was not learned. Verify the unlearned actuator is physically rotating. A common cause of this code is an actuator that's electrically okay, but it fails to physically rotate, for example, with stripped gears. If the unlearned actuator is not physically rotating, replace the actuator, otherwise replace the control module. So we could have stripped gears. Here's just an example of a broken one right there, and we got some chipped teeth. So this is also a good view to see what it looks like, right? So we have our motor here, the worm gear, and that turns this gear or reduction gear. There's another gear that sits here, that's sitting over there on the table there. And that gear, the top part turns off of this. The bottom part turns this. and that bottom part's kind of small. So if that bottom part hits this non-tooth part, it's not going to spin. All right, could have breakage in there, and that would cause an issue. It is interesting. Looking through, searching, researching for this, there are companies on the ones that have more common failures with these. There are companies out there, aftermarket companies, that make replacement gears for these. You pop the case off, you throw the replacement gear in, put it back together, slap it in the car, and you're good to go, right? So it's a different material, or maybe it's just an OE replacement or whatever. But obviously from the manufacturer, you have to buy the whole assembly. But there are companies that cater to just replacing, hey, this one gear right here fails on these thousands of cars, so we will make one. And, there you go. You have a replacement gear and you can fix it and you're good to go. So, gotta love ingenuity of people out there, right? So that is one problem. That's probably the most common problem you'll see. And that'll happen maybe if your linkage gets messed up, or if Mr. Squirrel or Mr. Chipmunk makes a nest in there. Seen that happen before. Blower motors too. Rodents like to make nests in the blower motor for some reason. So you turn it on and it's making a noise or whatever. You pull it down and this is full of nests. I'm sure you've probably seen that before too. Definitely issues you can have that are not going to throw a code. It's electrically going to be working fine. It's just physically not working fine. All right, so let's go live on the tool here. All right, so I got my Acadia. Let's talk about two different parts of the scan tool. So first off, we saw all these sensors and these actuators and these components that we need to test. You want to test them to verify that they're working electrically, right? So what we would need to do is in the guided component test, if you have a Snap-on tool with the guided component test, so that would be Zeus, Verus, Verdict, Modus, Triton, Vantage. Any of those tools that have a scope are going to have the guided component tests in there. So we go in and load the vehicle. This is our database of over 5 million tests. Goes back to 1981, covers most of the brands we cover. And you'll notice on some vehicles, we have HVAC system. And then on this, we have 12 different category or 12 different things that we can test in here. So let's try the actuator first. So the AC fresh and recirc door actuator. So go into component information, see what it's supposed to look like. Recirc actuator is a 5-wire, 2-directional electric motor that uses a feedback potentiometer. Ignition voltage, low reference control, 5-volt reference and position signal circuits enable the actuator to operate. The control circuit uses either a 0, 2.5, or 5-volt signal to start the actuator movement. When the actuator is not moving, the control circuit value is 2.5 volts. A 0 or 5-volt signal commands the actuator movement in opposite directions. When the actuator shaft rotates, the door position signal changes between 0 and 5 volts. So we can see over here, there's my connector view. And then we can also go down and we need to do an actuator recalibration we talked about. And then here's where we're going to check it. So pin 5 is ignition voltage. Pin 6 is recirc door control voltage. 7 is low reference. 9 is position signal, and 5-volt reference. So if I go and do a DC voltage test on this, let's see, should be about 12 volts on my ignition voltage. And if that's okay, move it to the control wire. Should be 2.5 volts, 0 volts when it's moving in one direction, 5 volts when moving in the other direction. If that's okay, we're going to move it to the position signal. And then when the mode door is moving, the voltage should change with no dropouts or glitches. So we should see it go back and forth, up and down. So I can actually simulate that right here. So if I go to view meter, it's going to set my voltage where it needs to be. It's going to set my time where it needs to be. So if it's at rests, all right, we said what, 2.5 volts or so, right? So that's probably around about there. So there's that rest. If we go down to 0 volts, it's moving in one direction. If we go up to 5 volts, it's going in the other direction, right? There's 5 volts. And if we see for checking the position sensor, it should go up and down smoothly with no dropouts or glitches. That's it. We don't want to see any dropouts. So that's my actuator. We also have a blower motor, right? So we got the blower motor, and that runs off of pulse width modulation, right? So we have blower motor's permanent magnet DC motor. Use blower motor control module to vary the speed of the motor. So if I go over here, and we can do a duty cycle test on this. So duty cycle, remember how it said it's going to be on ground longer than it is off. So that's a % duty cycle. So if I hit view meter, it's going to open my meter and it's going to give me a duty cycle now. So I got to change it over to duty cycle. There we go. So it's going to give me a duty cycle. And right now I'm running about 50% duty or so. There's 50% duty right there. All right, so if I was running a 10% duty, it should be on one side. And it should be, 90 or 100% duty on the other side, depending on how high it's going. I would say on high, it's probably got to be at 100% duty off, and then 0% or a very low percentage when it's on. So this is just graphing the percentage of duty cycle here is what we're seeing. So we'd be able to see that on the screen as well. And if it's not doing anything, if I move it to high and it doesn't move, then we know we have a problem there in the line. All right, so that's testing a couple things. The sun sensor's in there too. So we can do a voltage test on the sun sensor. So that's a 0 to 5 volts output signal is what we get. In order to test it, should be somewhere between 0 to 5 volts. If not, perform the outer range signal test. If it's okay, voltage should change when sunlight is added or taken away. So you can do this out in the sun, put your hand over it, and you should see the voltage go up and down as we do that. All right, so that is our testing. Now let's go to the scan tool side. So any of our scan tools will be able to do this as well. So if I wanted to, I can go into the HVAC module itself and it's in functional tests. But since I have a Zeus, I have my quick link to service resets and relearns, which makes it easier. This is going to list anything we need to reset, relearn on the vehicle. So I'm going to go down to my HVAC category, heating, ventilation, and air conditioning. And then say I wanted to replace or relearn the actuator. I'm going to come in here and it's going to give me functional resets, and I have the recirc door open and close, recalibration test, and then the afterblow configuration as well is in there. But before I do that, let's get a little bit more information. So if you have Shopkey or Mitchell, you can come in here to built-in repair information and get that information and never have to leave the tool as well. So I'm going to pass through my username, pass through my password, pass through the vehicle. And then it's going to pull up my actuator in here for me. Hit replace. And then we'll come down here and we've specifications, TSBs, testing, component connector. How about a wiring diagram? I want to be able to test this. So we made some changes in the wiring diagrams a couple weeks ago. And first off, we're going to drop you off on the right page. So in my automatic AC circuit on page 3 of 5 is where my actuators are. I'm going to pull that up. And then you see all my actuators are highlighted. So I'm going to dim those down a little bit. And you'll see it goes across the page over here. Goes over to my HVAC control module, which is there. Now let's zoom in. You see my mode door actuators there. Just going to move this over a little bit. Oops. Dragged it a little too far. Keep going. Now let's say I wanted to test this temp door motor right here. And I wanted to see pin X3, connector X3. So this is new. So if we go into X3, it's going to do a little search for me, and we want to see the connector. So we'll go in there, and that's going to pull up my information on connector X3. Right, so there we go. So it's on, there's a couple X3s in there, BCM, ECM. So it's on the HVAC module. Pops me down there, and there's my connector X3 on my HVAC control module right there. So I have it right on the screen, easy to see. If I scroll down a little bit, it's going to show me what each of those pins does. Right, it's going to tell me the wire color as well. All right, so we have all that information at hand. Once I've done that, once I've tested it, once I've confirmed that I need to repair it and then I replace it, I need to do my actuator recalibration. So I'll just go in there. And it's going to load the test real quick. And it says you need to use this procedure after replacing one or more actuators. When replacing the control module, the self-calibration starts automatically after the module is replaced. Do not adjust any controls on the HVAC control module while the self-calibration procedure is in progress, or improper performance may result. It can take up to 40 seconds to complete, and we need to start the engine and select calibrate on the continuing screen. Now, if this takes 40 seconds, I'm not going to wait for 40 seconds for that to happen. So if we hit continue, it'll go through and it just functions the actuators. This afterglow configuration is super easy. Remember, we talked about that. Dries out the evaporator core, gets rid of smells and all that good stuff. So that's pretty easy to do. We just go in here, key on, engine off. We hit continue, and it is super simple on off. So do I want it on or do I want it off? I hit on a real life car, that would say on, and then we're done. It saves it. And then we're done. Next time the car shuts off, we'll have that afterglow happen. All right. Otherwise, if I want to test these individual actuators, I can go into my HVAC module. So this one. Controls are for the knobs and stuff. Functional tests. And I should have a few different controls here. Let's see. So we have mode door positions, recirc door, lower motor speed, left temperature door, right temperature door. Right. So it gives us different actuators. So if I want to test the mode door, I can hook up to the mode door, hit mode door position, and then I'd be able to test that while functioning it from floor to defrost. Right. I can function it back and forth that way. Simple bidirectional control while I'm testing it with the scope makes life a little bit easier that way as well. All right, so that is HVAC electronics. And with that, that is our time here today. So make sure you tune in for new diagnostic content every week. We will be premiering a new video every Wednesday at 7 p.m. UK time. So make sure you check it out on the YouTube channel. If you're watching, well, of course, you would be watching this on YouTube, but make sure you subscribe, thumbs up, ring the little notification bell so you know anytime we post new content. And it's youtube.com/SnapOnDiagnosticsUK. With that, time for questions. If you have any questions, just feel free. Once again, if you're watching this on a premiere, just leave it in the live chat and we'll answer those. Otherwise, leave a comment under the video and we will get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've given you today. Hopefully we'll see you next week. Hopefully you can watch and see you on any of our other videos. Have a good week, have a good night, and take care.